Dear students, now the next topic is structure of amines. Amines possesses 3 bond pair and 1 lone pair in the sp3 hybridized orbitals, and the bond angle between the two bond pairs is 108 degree. It is clear from the diagram that the geometry is tetrahedral or pyramidal, but the shape is trigonal pyramidal because non-bonding electron pair is not considered for determining the shape of the molecule. So regarding the structure of the amines, there are three main points to remember: that nitrogen is trivalent, number 2 sp3 hybridization, and number 3 lone pair of electrons on the nitrogen. Now the next topic is classification of amines. Dear students, amines are broadly classified into three categories: primary, secondary, and the tertiary. Primary amines contains one carbon group directly bonded to the nitrogen atom, and there are two hydrogen atoms, as you can see from this diagram. Similarly, secondary amines contains two carbon groups and one hydrogen. Yes, you can see from this diagram, this one and this one. And finally, the tertiary amines, which contains three carbon groups, are directly linked to the nitrogen and there is no hydrogen, as you can see from the diagrams. So remember one thing, that the lack of this hydrogen does not allow the tertiary amines to make intermolecular hydrogen bonding with the another same type of molecules, which ultimately results in the lower boiling point of the compound. So the next topic is physical properties of the amines. Here we will discuss the solubility and the boiling point of the amines. Both these topics are based upon the concept of intermolecular hydrogen bonding. It has been observed that amines up to 6 carbon atom chain are generally soluble in water, as they are able to form the hydrogen bonding with the water. Similarly, all the primary, secondary and tertiary amines are soluble in water. Also, the reason is same, as they are also able to form intermolecular hydrogen bonding. But dear students, I would like to ask you that, as I have taught you earlier, that tertiary amines do not contain any hydrogen directly linked to the nitrogen atom. So can you guess how the tertiary amines are soluble in water? The presence of the three bulky alkyl groups also decreases the solubility of the tertiary amines. So students, kindly tell me your answer. Dear student. Okay students, now here is the answer. You can see in the figure 1 that primary amines can form three hydrogen bonds. Two bonds out of which is formed by coordinating or donating its own hydrogen with the oxygen of the water molecule, and one of the bond is formed by accepting the hydrogen from the water molecule by the electronegative nitrogen atom present in the amine. Similarly, the secondary amines also form two hydrogen bonds, one by donating its single hydrogen and one by coordinating with the hydrogen of the water molecule by the nitrogen. And in the tertiary amines, you can see there is no hydrogen to donate, but in this case, nitrogen present in the tertiary amines can accept the hydrogen from the water molecule. As you can understand from the diagram here, that nitrogen is donating its electron pair to the hydrogen, and this interaction leads to the formation of intermolecular hydrogen bond between the ammonia and the water and enables it to dissolve in the water molecule. So now in this way we have come to the conclusion that primary, secondary and tertiary amines are soluble in water. Thus, on the basis of extent of intermolecular hydrogen bonding, we can say that amines are more soluble than the hydrocarbons, as they are more polar, but they are less soluble than the alcohols because they are less polar than the alcohols. Next is boiling point of the amines. It totally depends upon the strength of intermolecular forces that is present between the amine molecules. Here we can see that there is intermolecular hydrogen bonding that is predominantly present in primary amines. of the availability of the two free hydrogen that can coordinate with the nitrogen of the second molecule of the amine. But in case of secondary amine, there is one hydrogen free that can form the hydrogen bond with the nitrogen of the another molecule. But in case of tertiary amine, we can see here that there is no any hydrogen present that can make the hydrogen bond with the nitrogen of the another tertiary molecule of the amine. On the basis of these characteristics, we have found that the amines with one carbon atom that exist in the form of a gas, whereas the amines up to 3 carbon atom exist as a liquid, where amines are solid in nature. On comparing the boiling point of the amines with that of alcohols, we have found that amines have lower boiling point because in case of amines there is nitrogen atom and it is less electronegative than the oxygen atom present in case of alcohols. Dear students, this fact can be further confirmed when we analyze the given tabular data regarding the boiling point of the hydrocarbons, amines and alcohols of same molecular mass. We can easily identify the difference that hydrocarbons are the compounds with lower boiling point and amines have higher boiling point than the hydrocarbon, whereas alcohol possess higher boiling point than the amines too. This whole difference is totally based upon the intermolecular forces of difference that exist between the molecules and the polarity of the molecules. Yes, as we have previously studied that in case of hydrocarbon, there is weak van der Waals forces of attraction that exist, and in case of amines, there is intermolecular hydrogen bonding. What the extent of this intermolecular hydrogen bonding is lesser than in comparison to the alcohols, because in case of alcohol we have seen that the oxygen atom is very electronegative than the nitrogen atom present in case of amines. Thank you, students. Okay students, now here is the answer. You can see in the figure 1 that primary amines can form 3 hydrogen bonds, 2 bonds out of which is formed by coordinating or donating its own hydrogen with the oxygen. Hello students, today we are going to study the methods of preparation of amines. So here you can see there are 6 methods. So number 1 is reduction of nitro compounds, number 2 is ammonolysis of alkyl halide, number 3 is reduction of nitriles, number 4 is reduction of amide, and number 5 is Gabriel thalamide synthesis, and number 6 is Hofmann bromamide degradation. But each method has its own merits and demerits. So let us discuss them one by one. The first method is reduction of nitro compounds. Dear students, remember one thing, that all the aliphatic and aromatic compounds can be converted into respective amines. Here we have 2 different ways for the reduction of these nitro compounds. The first one is catalytic reduction. It is carried out by passing the hydrogen gas in the presence of catalysts like nickel, platinum or palladium in alcoholic medium at room temperature. But in the second method, nitro compounds are reduced by a mixture of metal like tin with HCl or iron with HCl. But the iron with HCl is preferably used because in this method the byproduct produced is iron chloride, which easily gets hydrolyzed to give HCl. Therefore, in this way HCl is again regenerated. So this method just minimizes the consumption of HCl. So the second method is ammonolysis of alkyl halides. This method is also known as Hofmann ammonolysis method. This method of preparation of amines have 2 main drawbacks. Number 1, it is applicable for the preparation of only aliphatic amines. And number 2, we get a mixture of primary, secondary, tertiary as well as the quaternary amines. So now let us discuss it in detail. Dear students, it follows SN2 type mechanism in which Ammonia acts as a strong nucleophile and it attacks over the alkyl halide molecules and replaces the halogen attached already with the alkyl halide and results in the formation of quaternary ammonium salt. This reaction is carried out in a sealed tube at temperature 373 Kelvin, or we can say 100 degrees centigrade. The quaternary ammonium salt thus obtained is further reacted with strong base like sodium hydroxide or the potassium hydroxides, and at last we get a mixture of primary, secondary and tertiary amines. With this, now the third method of preparation of amine. It is the reduction of nitro compound, isonitriles. Students like the first method, that is the reduction of nitro compounds. This method is also same. Therefore, alkyl or aryl nitriles can be reduced into respective amines by three different ways. Number one is the catalytic hydrogenation, in which we react the hydrogen gas in the presence of Raney-nickel. Raney-nickel metal is just the spongy nickel metal, and the other method is by using the strongest reducing agent like lithium aluminum hydride in the presence of ether. And the third method of reduction of nitrile compound is by reacting the sodium amalgam in ethanolic solution. This third method of reduction of alkyl or aryl nitriles using the ethanol and the sodium amalgam mixture is also well known by the name of Mendius reduction. Here is one important point to remember is that the amine formed in the product contains one carbon atom more than the parent nitrile or isonitriles. In this way, a particular nitrile or isonitriles can be converted into respective amines. But if we take isonitrile, isocyanides or the isonitriles as a reactant, then we get secondary amine as a main product, isonitriles. Students like the So now the fourth method of preparation of amine is by reduction of amides. So the amides can be reduced using the strong reducing agents like a lithium aluminum hydride, proceeded by the hydrolysis to get primary amine. So with this, the next fifth method of preparation of amine is Gabriel phthalimide synthesis. Students, as you have learnt earlier that phthalimide is a derivative of phthalic acid and it is acidic in nature. So firstly, it is neutralized with the ethanolic solution of base like KOH, that is potassium hydroxide, and it forms a salt named potassium phthalimide. So in the second step, this salt forms acts as a strong nucleophile and it is allowed to react with the alkyl halide, and it follows SN2 type mechanism which leads to the formation of an alkyl phthalimide followed by the basic hydrolysis to form primary aliphatic amine. Dear students, the main point to remember here is that aromatic primary amines cannot be prepared by this method because aryl halide do not undergo nucleophilic substitution reaction as there in case of alkyl halide. Now the last method of preparation of amine is Hofmann-bromamide degradation reaction. It is very convenient to learn the mechanism of this reaction from the name. Bromamide degradation means or aromatic amides can be reacted with bromine in the presence of strong base and we get amines which may be aliphatic or aromatic. But one main point to be remembered here that the amine produced contains one carbon atom less than the parent amide. The equation can be balanced by reacting the products like sodium bromide, 2 molecules and 1 molecule of sodium carbonate and 2 molecules of water. So with this, thank you students for listening this video patiently. Thank you very much. So now the fourth method of preparation of amine is by reduction